Hello students, welcome back to this lecture series of M.Sc. Part 1 Physics, Mathematical Methods in Physics. In the last lecture we discussed about the Taylor series. So in this lecture we are going to discuss about the Laurent series. So first we first discuss about the Laurent series. What is Laurent series? So if we have the form of the series, that is summations over n minus infinity to plus infinity Cn z minus z naught power n. So this series can be we write in the form in the two parts. Okay, this is equal to, I'm writing here. So this is equal to summations over n is equal to 0 to infinite Cn z minus z naught power n plus summation over plus 1 to minus n is equal to 1 to minus plus infinity c minus n z minus z naught or n. Okay, so this series or this form of the series we can write in this two parts. So here the power of this series, it is positive and the negatives. Okay, so this Cn we can write, or this Cn, it is a characterization coefficient. This can be write Cn is equal to 1 by 2 pi I closed integral over c f of psi and z psi minus z this. Okay, this is a characteristic coefficient of this Cn, and for the c minus n, if I write, so this thing is equal to minus n 1 by 2 pi eta close integral over c and this z psi minus z f of psi dc like that. Okay, so this is c minus n is equal to 1 by 2 pi to close c. So this is characteristic coefficient of this this series and Cn for this series. So if I consider the circle, or if this z naught, this is a fixed point, and we expand around this point, so this series is, if f of z is analytical and this series is converges to this functions, analytical functions, so that is f of z, and we can write if this f of z, which is the point functions, at this functions this series is analytical. So if we expand to z naught, this series around is z naught, so this is converge in this region, and this regions maybe it is if I consider the by the radius of convergence, so it is absolute z minus z naught is less than r. Okay, so in this region, and this z naught is the center of this circle or this entire complex planes. Okay, so this series, if we expand around this z naught, then this f of z is analytical, and this converge this series at this functions. Okay, so same things for this second terms, that is c minus n z minus z naught. So if I write region for this thing, so it is z minus z naught, the absolute z minus z naught is greater than small r. Okay, so this r is defined the radius of convergence, or the regions where this we can expand the series. Okay, and this z naught is the center of the series. So this is called the Laurent series. Okay, so here we are going to prove this one theorems, that is the f of z is analytical, that is what we consider this f of z. Okay, at this analytical means this exists the CR equations. Okay, analytical inside the annular regions where r is less than z minus z naught is greater than r. So for this series, the region is this thing, this z minus z naught is less than r, and for this second terms, that is region is z minus z naught is greater than, or magnitude of the z minus z naught is greater than the small r. Okay, so this is the annulus regions. Okay, r is less than z minus z naught is greater than r, and on the bounding circle C1, okay, this is C1 loop, one closed loop we considered, and z minus z naught is equal to r, radius of this C1, that is r. Okay, and C2, that is z minus z naught is equal to r. So this is another one circle we are considering, and the radius of this circle, that is capital R. Okay, then the f of z can be represented by the Laurent series, which is equal to f of z c naught plus c1 z minus z naught plus c2 into z minus z naught square plus we can expand up to the n, and then next series for this thing. Okay, so this for this you can expand like this: c minus 1 z minus z naught plus c minus 2 divided by z minus z naught whole square plus so on. Okay, so here we can expand up to the n terms. Okay, so this expansion for the first series for this one, and this second this expansions for this second thing. Okay, so here this is just introduction part of this theorem. So let's we try to prove these theorems. Okay, so this is f of z. Okay, so this divided into the two parts. The series one is this thing and second one is this. Okay, so I am considering the one arbitrary points, that is z in this annulus region. So we know this r is less than z minus z naught is less than r. This absolute value is less than the capital R. So if I draw the region for this thing, so it is, okay, this is the annulus region, and this z naught is defined with something center of this thing, of this two circles. Okay, so radius of this is c1, and radius of this, that is a small r, and this is c2, and radius of this circle, that is r. Okay, so in these regions, if we expand the series, that is f of z, so that is Laurent series, and here I am considering the one arbitrary point, that is z. Okay, so and on these c1s I consider the psi, and here also I consider the psi too. So by and one more things, that is this is rho. Okay, so by using this Cauchy integral formula for the multiple connected regions, by extension formula for Cauchy integral formula, extensions formula for Cauchy integral for the multiple connected regions. Okay, okay, so we already discussed these things in the previous lecture, so I am directly write the formula for the multiple connected regions. So here these two loops C1 and C2, if I integrate or apply this integration over this loop C1 and C2, so this is like this: the f of z is equal to 1 by 2 pi I close C2. Okay, so first I am considering this C2 loop, and it is f of psi divided by psi minus z into d psi. Okay, this psi is over this C2. Okay, so This is for the C2. Now if I apply the formula for this C1, so it is minus 1 by 2 pi item close integral over C1 into f of psi. Now the psi on this C1, okay, so it's also psi minus z this side, okay. So this is expression for this thing, okay, f of z. So this now same what we did in the Taylor series. If we take this denominator, that is 1 by psi minus z, 1 by psi minus z, we can rewrite these things this in the term of z naught. So psi minus z naught minus z, okay, and it is equal to, if we take out the commons, that is psi minus z naught 1 minus z minus z naught, or divided by psi minus z naught minus 1. Okay. So if I expand these things by using the binomial theorem, so like this we get 1 by psi minus z naught 1 plus z minus z naught divided by psi minus z naught, plus the binomial theorem, we know the 1 plus x square plus x cube plus xg. If 1 minus x power minus 1, so we can expand like this: 1 plus x square plus x cube and so on, okay. Okay, so here third term is z minus z naught divided by psi minus z naught square, okay. Oh, sorry, square, and the plus dash up to the n we can expand this series, okay. So this, after multiplying this 1 by psi minus z naught, so this become, it is equal to 1 by psi minus z naught, okay, plus z minus z naught divided by psi minus z naught square, plus z minus z naught, this is square, and if multiply, so power become psi minus z naught 3, okay. So this is 1 by psi minus z naught, okay. This is expression for these things. So if I put here, or these things, if I write, this is I1 minus I2, I1 plus I2, okay. So this I1 becomes now 1 by 2 pi to close C2 f of psi divided by psi minus z and this psi, okay. So I am now consider this I1 is equal to this thing and I2 is equal to this, okay. So I am just I1 consider, so I1 is equal to 1 by 2 pi I close C2 f of psi divided by psi minus z and this, okay. So for this 1 by psi minus z, so 1 by psi minus z is equal to this thing. So just I am substitute here, so it is 1 by 2 pi I close C2, okay. So f of psi, first term, that is psi minus z naught and this psi, plus second term, that is plus z minus z naught. We take out this common because it is not depend on the psi, okay. So z minus z naught divided by 2 pi at close C, and this f of psi divided by these things, that is psi minus z naught a bracket square, okay. Psi minus z naught bracket square, this plus third terms, that is we can write up to the n. So third terms is like z minus z naught n divided by 2 pi eta close c2, close integral over c2, and this is f of psi divided by psi minus z naught n plus 1 into this side. Okay, and other term also present here, that terms is called the remainder terms. But if we go the n if this n approach to infinity, then this remainder terms, it is equal to 0. Okay, so we are not considering that terms. Okay, so we just considering up to the n plus up to the n plus 1. Okay, so these things we can write in the term of the so this I1 we can write summations over n is equal to 0, or now one more point, this we integrate along this C2. Okay, but this z minus z naught, this is equal to rho if I consider. So according to the principle of deformation path, with this, if we change this path C2, okay, we replace this C2 with the rho. Okay, that is what we this. Okay, so we just okay, so this path is C I am considering. So just according to the deformation of path, we change this C2 with this C. Okay, so this C2 change with the C. So here okay, so I am right here, this summations or 1 by 2 pi I close C. Okay, now this C, and why? Because this we can write as like this, R is less than rho and it's less than capital R. Okay, this rho is equal to z minus z naught. Okay, that is these things C. Okay, so just we change the path. Okay, according to so the value of the integrand is does not change if we change the path. Okay, by the according to deformation path. So that's why I am taking these things. Okay, so 1 by 2 pi eta close C f of psi. Here I am directly right here. I1 is equal to summation over n is equal to 0 to Cn z minus zn. Okay, so now the Cn I am just considering these things, that is z minus z naught power n divided by 2 pi eta, or this, sorry, this thing, that is 1 by 2 pi close C integral f of psi minus z naught n plus 1 d psi. Okay, so this is Cn and this is I1's this is characteristic coefficient of the Cn. So I1 becomes I1 that is equal to summation over n equal to 0 to infinite Cn z minus z naught. Okay, so this is just similar things. Okay, so this is about the I1s. Now if I write expression, this is right there. Okay, so now next I am right for the I2. Okay, so I2, that is minus 1 by 2 pi I close integral over C1. Okay, the here path is what, this path C1. So we integrate along this C1. So it is f of, now this psi on psi now on this C1. Okay, so f of psi, it is psi minus z and d psi. Okay, so we just change these things. It is 1 by 2 pi the close integral over C1s, that is psi minus z naught, okay, or as I am right, and it is psi minus z naught into it is z minus z naught. Okay, so here n minus 1 and here is n. Okay, I am directly write these results. If we put this psi minus z naught, so here is the minus signs, we can write these things, okay, for the n terms. Or also you can write this okay, I am write all things. So it is f of psi divided by z minus z naught, okay, d psi, plus for the second term, that is 1 by 2 pi iota close integral over c1s, and f of psi divided by z minus z naught square, and here is the psi minus z naught 1 power 1 into d psi. Okay, so like this we can expand up to the n's. So here is a n and here is a n minus 1. Okay, this thing is a n minus 1 and this thing is a n. Okay, so we can expand up to the n terms, and after that n terms we having the n plus 1 like that. So these terms, if we approach to n is equal n approaching to infinity, then the other, that is n plus 1, that we are neglecting these things. Okay, so because this series is a conversion in these regions where z minus z naught is greater than r. Okay, so in this region, okay, this series is converged in these regions. Now this I2 for the I2 I write this I2 is equal to 1 by 2 pi I close C1s. Now this C1s, same things by the principle of the deformations, we can change this C1s or this path with the C. Okay, so here is a C. That C path is this inside these regions. Okay, so if we change the path, the integrand that does not change its value. Okay, so it is f of psi divided by z minus z naught, and this is n, and here psi minus z naught n minus 1 d psi. Okay, okay, so this is I2. Now if I just addings, or if I write in this forms, that is I1 is equal to summations over n is equal to 1 to infinite, that is c minus n z minus z naught is equal to power n. Okay, okay. So okay, so c minus n, here is a cn, and c minus n if I write, so it is like this, minus n, not it is c minus n, c minus n is equal to 1 by 2 pi iota close c f of psi divided by it is psi minus z naught n minus 1. Okay, so psi minus n, let me check. Okay, here mistake. This is divide by z minus z naught. Okay, so this is right now. Okay, so z minus z naught, this is in the divide. Okay, so c minus n is equal to 1 by 2 pi iota close c f of psi minus z naught. This is a cn. So this series I1 is equal to summation over n is equal to 1 to infinite c minus n. Okay, so this is the characteristic coefficient. Now if I add these two things, or this I1 I2, so it is like this. if f of z is equal to I1 plus I2, so this become summations over n is equal to 0 to Cn z minus z naught power n plus summation over n is equal to 1 to infinite c minus n, and it is z minus z naught. Okay, so this we can write summation over n is equal to minus to plus infinity cn z minus z naught power n. Okay. So this is what we seen in the first definition of this Laurent series. F of z is equal to this expressions. So this series is converged in these regions, okay, in these annulus regions. If I write, this is for, okay, so this rho is a absolute z minus z naught, and this series region for this series we can write, or this is rho is less than is greater than r. Okay, this small r is defined the radius of this C1, and for this region I2 I1 we can write it is, okay, rho is less than, and rho is this thing z minus z naught. Okay, so this is about the Laurent series, and we can also expand this series. If I expand, so we get so f of z is equal to, that is c naught plus c1 z minus z naught plus c2 into z minus z naught bracket square plus so on. Okay, and this is for the this term, and for the second term if I expand, so it is like this, c minus 1 divided by z minus z naught, okay, and plus c minus 2 divided by z minus z naught whole square, and so on. Okay, so this is the expansion of this f of z. So this power series which is converged in this region, and if these functions what we consider, this is the analytical functions. Okay, so this is about the Laurent series which is we expand around this z naught. Okay, so let's stop here. We'll